Hello everyone. So today let's solve the problem. This one, 2, 3. So this was asked in the educational code forces around 29, right? So you can just go through the question. It's very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So let me do one thing. Let's start yeah, I'll just summarize the question so that it will be easier for us to solve the problem. Yep. Let me let's see what the question states here. Just give me a second, 1 second here. Yep. So there are guys Alice and Bob. So this is the Alice and Bob question. Yeah. So whenever I hear the Alice and Bob, so this is going to be this one. Something there will be something twist actually. Whenever I hear the name Alice and Bob, right? So this is fine. Let's see Alice and Bob play 1, 2, 3 game here. Alice and Bob play 1, 2, 3 game for the K rounds. K rounds. For the K rounds. Where 3 beats 2. Where 3 beats 2. Yep. And 2 beats 1. Where 3 beats 2, 2 beats 1, and 1 beats 3. 1 beats 3. Yep. So Alice and Bob play a 1, 2, 3 game for the K rounds where 3 beats 2, 2 beats 1, and 1 beats 3. Their next moves depend only on the previous number they chose, right? So their next moves um, depend only on the previous numbers they chose. So let's predict what we need to do here. We have to predict the final points of the K games. We have to predict. So let me write here predict. We have to predict the final points of the K games given their starting numbers and transition tables. Given their starting numbers and their transition table. So this is the question basically. Let me read the question. Let me read out the question very loud. Just listen to this carefully. Yeah. Alice and Bob play a 1, 2, 3 game here. 1, 2, 3 game for the K rounds. For the K rounds. Where 3 beats 2, 2 beats 1, and 1 beats 3. Their next move depends only on the previous numbers they chose. Previous numbers they chose, right? So what we need to do, all we have to do is we have to predict the final points of the K games given the starting numbers and the transition table. So this is the question mainly. Yeah, let me remove this one entirely. Now let's come to the input output part, man. Yep, let's come to the input output part. So just give me a second why this is not working, man. Yeah, so here we have been given 10, 1 and this one. So basically we have to get the output 1 and 9. Yeah. So yep, let's do one thing. Let's consider the same example. Let's consider the same example actually. Yep, let's consider the same example and let me show you this one, the approach actually. Let me show you the approach. So what we will be doing here, basically, we will be making use of the cycle detection on the states. This is the pure graph based problem, man. Yeah, we have been given the h1 1 1 1 1 1 2 2 2 2 this one with a value 1 1 1 2 2 2 respectively, right? The input basically here, right? So this is fine, I believe. Let's discuss this one. The approach that we'll be going with here is using the cycle detection on the states, right? Just to avoid simulating all the K moves, right? So this will be easy actually. That is the reason I chose this. Yep. Now, first, so let's consider the same example for the approach as well, man. Yeah, I'll just show it to you here itself. The game one, let's consider the game one here. Let's consider game one here. So Alice equals 2. Initially, Alice equals 2 and Bob equals 1. Bob equals 1 here, right? 2 bits 1 here, right? 2, quite obviously, 2 bits 1 here. So Alice is, we can just consider Alice plus 1. Yeah, Alice plus 1. Right, so let's move on with the next numbers. Let's move on with the next numbers here. Alice always picks 1. Bob always picks 2. Right? Alice gonna pick 1 always and Bob gonna pick 2 always. Just remember this one. Alice always picks 1 and Bob always picks 1. Right? So this is fine, I believe. Now let's move on with the game 2. So let me write it over here. Game 2. Right? So now Alice equals 1. Alice always gonna pick 1, right? Bob always gonna pick 2. Sorry, not 1. Alice gonna pick 1 here. Bob is gonna pick 2 here this time, right? So here, 2 beats 1. So we can just write in this way. Bob plus 1 this time. Bob plus 1 this time. So this is fine. From the game 2 onward, pattern repeats. from the game 2 onwards pattern repeats actually 1 2 1 2 this one Alice 1 B2. So every time Bob gonna win here. So every time Bob gonna win. So we have to count points until K is equivalent to the 10. So we have been given K10 here. K initially 10 to 1 they have given, right? K initially it is 10. So we have to count the points until K equals to 10 using the cycle detection. Using the cycle detection. So Alice has won only once and Bob has won 9 times. Until K equals 10 we are going, right? So Alice has won only once and the Bob successfully has won 9 times, right? So output is 1 9. So the output that we got here is 1 and 9, which is equivalent to the output that they have mentioned for the example 1 within the question. Very simple one, right? So our approach works absolutely correct. So what is the approach that we'll be going with? Accordingly with what we have discussed, we will be making use of the cycle detection on the states Alice, Bob, just to avoid simulating all K moves, right? So if we simulate all the KMOs, this one, the approach is going to be huge and the code is going to be huge as well. So to avoid that one, we'll be making use of the cycle detection on the states. Just, yeah, we can just go with the cycle detection on states, right? So this is fine. Now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity? Time complexity would be quite obviously because of 9 actually. Here, only 9 possible states, right? Only 9 possible states. Basically this one 3 into 3, right? Basically 3 into 3. So only 9 possible states here, 3 into 3 are processed for the cycle detection. So we can just write here the time complexity, overall time complexity would lead to big of 9. So what would be the space complexity here? The space complexity would lead to big of 1. So arrays are fixed size here. Arrays are fixed size. We can just go with 4 into 4, right? 4 into 4 and 10 elements. 4 into 4 and 10 elements, right? So overall time complexity would overall space complexity would lead to big of 1. The time complexity and the space complexity for the code that we'll be writing in the future would be big of 9 and big of 1 respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? So we'll be making use of the different utilities. So I'll just import here java.util.star. This is fine. Let me go with public class. Let me go with main here. So this is fine. So I'll just go with m main. So this is fine. So within the main, I'll just go with the main method here within the main class. So let me make use of the scanner here, right? Scanner variable sc new scanner. So this is fine. So let me go with system dot. Let me go with system dot in. So this is fine. The next step would be so we have to go with a k as well as let me go with a al and this one Bob. So this is nothing but this guy is Alice and this is Bob actually, right? 10 to 1. So this one long k equals sc dot next. Let me go with the next long actually. Yep. So let me do one thing. Let me copy the same thing here. So I'll just paste it over here. Again, let me paste it over here. So this one, I'll just change this one to Alice. So this is fine. And this one, let me change this one to Bob. Right. So this is fine, man. Yep. Next, what shall I do? Uh, let's move on with the further things. Yeah. So now it's gonna be int. So this is fine. A equals new int of 4 4. So this is fine. B equals new int of, so this one's gonna be 4 4 as well. Yep. The next thing would be let's go with a int if a is equivalent to new int of 10. New int of 10. Also, let me go with h equals new int of so this one also let me go with the 10 itself, right? So this is fine. Yep. Also e equals, let me go with a 0 minus 1, or let me go with correct this one order minus 1 1 1 twice actually. This is fine. 0 followed by -1 twice here, -1, and followed by 1 and 0 respectively, 1 and 0 respectively. So this is fine, I believe. Yep. So A of ij is nothing but the Alex next move, and B of ij is nothing but the Bob's next move. So that we know. A, B we have already considered. FA is nothing but the FA of state, next state, that is n that we have to encode, and H of state is nothing but H equals new int of 10, whatever I have written. H of state is nothing but when state first appeared. This will be helpful for the cycle detection basically. H, whatever we have considered the variable H, and E, whatever I have given 0 0 -1 double 1 0 -1 twice, finally 1 0. So that is nothing but the winner points for the state. One is this one. Alice will choose one. -1, initially -1 will be chosen by the Bob, and 0 is nothing but the draw actually. This is fine. Yep. Now let's do one thing. Let's move on with the further things. We have to read the Alice's transition table first. So this one will be for int I equals 1, I less than or equal to 3, I plus plus. So this is fine. And for this one, int j equals 1, j less than or equal to 3, and let me go with a j plus plus. So this one will be a of ij, ij equals scanner dot next, scanner dot next. Yeah. So let me copy this one. Let me copy this one. Same thing, we have to read for the similar thing. We have to read the Bob's transition table as well. And also we have to encode each possible state, nothing but the Alice, comma, Bob into the single number, nothing but from 1 to 9, right? So let me copy paste the same thing twice and make the necessary changes. This for loop remains same actually. So instead of A, this one Alice, we are done with the Alice. Now we have to go with the Bob's transition table, right? So this one will be of ij equals sa dot next int. So this is fine. Next, we have to encode each possible state, nothing but the Alice Bob into the single number 1 to 9. So this one has to be, let me delete this one entirely. Now this one has to be fa of this one. What do we call? Within the square brackets actually. So this has to be I minus 1, I minus 1 into 3 plus j, I minus 1 into 3 plus j, that is equivalent to uh, a of ij, a of ij. So this is fine. Minus 1, a of ij minus 1 into 3 plus b of ij, into 3 plus b of ij. So this is fine. Simple. Yeah. Now let's do one thing. What we have to do, so we have to go with the current state that is encoded as the single number. Just now we did the same thing, right? So this one, third one, just now we did the same thing. Now let's go with the current state and that is encoded as the single number. So I'll just go with a variable b, some random variable number. So this one will be int actually, int of let me go with the Alice here, Alice minus 1, al minus 1 into 3 plus Bob, nothing but bo, right? So this is fine, man. Yeah. So now what we will be doing, so we have to reset the points, meaning let me go with, let me initialize Alice to 0, also Bob to 0, also Bob to 0, right? So we are resetting the points. The next thing is, let me initialize T to 1, Alice to 0, and also Bob to this one. What do we call? Bob to 0 as well. So this is fine. T to 1. A, so we have considered A1 and B1. So this one, Alice and Bob, not Alice and Bob, this one. We are resetting initially to this one 0. This is fine. Yep. Now let's do one thing. We have to simulate until we have found or we find a cycle or run out of the game. So that itself is the approach, right? So that we discussed actually earlier. So I'll just write here while h of the variable b I have considered, right? B, if it is equivalent to 0 and k greater than 0, then uh, h of b, we have to increment this one actually. We have to increment t actually, right? Yeah, this is fine. Yep, we are just marking the step number of current state. Now, if the Alice wins, then we have to increment AL, variable AL we have considered for the Alice, right? So if E of BE, this one, if it is equivalent to the 1, then what we need to increment Alice, right? So this is fine. Else if E of B, the same thing, if it is equivalent to the 1, then what we need to do, we have to increment Bob, BO, variable BO, Bob wins here, right? So we have to move to the next state, and we have to make sure that one game is being played, right? So here I'll just, let's move to the next state here. If A of this one, BE, this is fine. The final one is one game played, meaning K minus minus. So this is fine, man. Let me come out of this one entirely. Yeah, so this is fine. Yep. Let's move on with the next steps. So let's go with the length of the detected cycle here. T equals T minus H of BE. This is fine. T equals T minus H of BE. So if the remaining games exceed the cycle length, meaning if here K greater than T, if K is greater than T, then let's do one thing. Let's move on with a for loop here. So this one will be for int I equals 0, I less than T, and let me go with I plus plus. So this is fine. So within the for loop, let's count the Alice's points in the cycle. So if E of BE, if E of B, if it is equal to 1, then increment the Alice. So this is fine. Next step, we have to count the Bob's points in the cycle. So I'll just go with else if here E of BE, E of B, if it is equal to 1, so then let me go with the B1 plus plus. So this is also fine. Next, we have to move to the next state. So I'll just assign B to the FA of BE, FA of BE. So this is fine, man. So let me come out of this one entirely. Now, what shall we do? So let's go with the number of the full cycles. So I'll just initialize Ti to k by t. Also, uh, let's add the Alice's points from the cycle. So this one AL equivalent to Alice plus Ti into A, this one A1. Yeah, this is fine. Next, Bob, nothing but the BO, the variable that we considered. So this one Bob equals Bob plus Ti into this one B1. So this is also fine. So this one has to be multiplication operator. This is fine. Finally, we have to go with the remaining games after the cycle. So this one has to be K equals K modulo T1. So this is fine. So let me come out of this one entirely as well. So we are left with only one step. We have to play the remaining games one by one. So let me make use of the while loop here. While if it is greater than 0, if it is greater than 0, then if of E of BE, so if it is 1, then let's increment the Alice. Let's increment the Alice. Else if A of sorry, E of B, right? So I have written this multiple times. E of B, if it is equal to -1, then we have to increment the BO. So we have considered BO for the Bob, right? BO plus plus. This is fine. Finally, let's assign BE to the this one FA of BE, right? FA of BE, right? So let me come out of this one entirely. So let's go with the final score, man. So I'll just go with the system out println here. So let me go with Alice plus this one. What do we call Bob actually? We need space, right? 1 and 9 we got here. Between the 1 and 9 output, we need space, right? So we have to go with the space as well. It ls plus we are appending space and we are just going with the plus nothing but the Bob actually, final score. So this is it for the code. Before checking the code with the different inputs or the examples, let me copy paste the signature starter template. So this is it for the code, one simple one actually. Whatever we had discussed in the approach, the exact same thing we have articulated in the form of code, right? So just give me a second here. So yeah, let me paste the signature starter template over here. I'll just come to the question. Let me copy this one. The output that I need to get here is, or that we need to get here is 19. So let me check the same. Hmm, L is already defined in main method. So this one has to be A1 actually. So I didn't change there at that point of time. Okay. So let me change this one. Let me run. Yeah, we are getting the output 10, 19 we have to get, right? So just give me a second. So let's check this while loop, man. So we are getting 10 here itself we are mentioning, right? That is our hope. So what mistake I have done here? Let's check this one. Mm, this is fine. K greater than 0. This is fine. I've written here E of this one BE equals 1. This is fine. We are incrementing the alice. So this is fine. Else if, so I'm just going with E of B. Oh, this one has to be minus 1. We run this one. We're getting 1 1. Still, this is wrong actually. Yeah. So, mm, might be. This is fine. This we have written correct itself. This, yeah, this is fine. This is also fine. So here, after this, there might be wrong thing somewhere over here. After this, actually, this we have written correct itself. This is fine. Let's check from here. Actually, now this is correct. Minus one b equals this one f a of b. This is correct. Actually, this is fine. Next, mm, so let's check the this one. Wait, again I have given here one itself instead of the minus one actually. So now I am getting this one. What do we call? 9 actually. Yeah. Now this is working. Yeah. Instead of the minus one, I have just given plus one. That was the main mistake, I believe. So let me copy this one. The output that I need to get here is phi 2. So those were the two mistakes. Phi 2 I am getting. So the last one I have to get 0 0. Let's check the same. Yeah, we are getting the correct output one. So let me copy this one entirely. Hit the submit button. Yep. Let me paste this one and hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. So wrong test on 1 second. So what is the wrong thing? First, let's check this one here. First answer different. Expected 8, found 4. Mm-hmm. Somewhere over here itself I have done wrong thing, I believe. This one I have to check from here. This one, this is fine. Alice and Bob, I have changed this one to the minus one. This is fine. Mm, 1 second. Oh yeah, here itself I have done the mistake, man. So this one I believe. So if E of B is this one, we have considered the variable A1 here, right? So I have given here Alice. I have to increment the A1 actually here, not the AL. So I hope this is the only problem, I believe. This is fine. Let me submit this again. Why this is asking for this thing? Yeah, let me do one thing. Let me give 863 here. Let me copy this one. Paste it over here. Yep. Let me hit the submit button. I hope this works for all the test cases. Now, the only change was instead of we were incrementing AL instead of the A1 actually. Ah, in a hurry, this one I chose AL I believe instead of the A1. So I believe this has to work now. Let's see. At any cost, this has to work now. Let's see. Yeah, now this is working. See, running on the test 27, actually 30. Yeah, you can clearly see here the verdict that we got here is accepted. Those were the total, those were the three mistakes actually, including the last one. Yeah, this one, this is fine, man. Now, uh, this is it for the solution part. Yep, this was simple one, right? Yep. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.